Every blockchain since Bitcoin has faced the same fundamental constraint, the blockchain trilemma. You can have security, decentralization, or scalability. Pick two. Bitcoin chose security and decentralization, sacrificing speed. Ethereum made similar compromises. Solana prioritized speed, but compromised decentralization with validator requirements that price out average users. Kaspa's founders looked at this problem from a different angle. What if the limitation isn't proof of work itself, but the linear structure of traditional blockchains? Bitcoin processes blocks sequentially, one after another in a single chain. This creates the orphan block problem where network propagation delays cause miners to create competing blocks, and only one survives while others get discarded. To prevent this chaos, Bitcoin intentionally slows down block creation to 10 minutes. That's not a bug, it's a necessary feature of sequential blockchain architecture, but it's also a massive bottleneck that limits Bitcoin to about 7 transactions per second. Kaspa demolished this constraint by reimagining the entire structure. Instead of a blockchain, a single chain of blocks, Kaspa uses a Blockdag, a directed acyclic graph where multiple blocks can be created simultaneously and all get incorporated into the ledger. There are no orphan blocks, because the architecture processes everything in parallel. Think of traditional blockchains like a single-lane highway, where cars must travel one behind another. Kaspa is a multi-lane system, where traffic flows simultaneously in parallel lanes, all reaching the destination without collisions. This isn't just incremental improvement, it's architectural revolution. So, the GHOSTDAG protocol manages this complexity. It classifies blocks as blue if they're well-connected and honestly produced, or red if they show signs of being adversarial or, just poorly connected. This classification system maintains consensus and ordering, all while allowing parallel block creation. The result? Bitcoin-level security with dramatically higher throughput. May 5th, 2025, marked a pivotal moment for Kaspa. The Crescendo Hardfork activated, implementing KIP 14, a complete codebase rewrite from Golang to Rust. This wasn't just a patch or an upgrade. They rewrote the entire protocol from scratch in a more efficient programming language. Rust offers memory safety without garbage collection, zero-cost abstractions, and performance that really rivals C++. For blockchain applications that require maximum efficiency, Rust is, honestly, just ideal. The rewrite, called Rusty Kaspa, was led by former DAG Labs developer Michael Sutton, with contributions from a global development team. The performance improvements are, honestly, staggering. Testnet 11 has been running since the middle of 2023, consistently processing between 2,400 and 3,000 transactions per second, over 10 blocks per second, and that's not just theoretical, it's live, tested infrastructure that's now running on mainnet following the hard fork. So here's what changed with Crescendo. Throughput increased from 1 block per second to 10 blocks per second, a 10-fold improvement. Transaction confirmation times dropped to, about 10 seconds. The network now handles 3,000 to 4,000 transactions per second in real-world conditions. But, speed isn't the only upgrade. Payload support was added, which lets users attach data to blocks. This actually enables smart contracts and applications that go way beyond simple value transfers. Developers can now build DeFi protocols, DAOs, games, identity systems, and even traditional finance integrations directly on Kaspa. Additive addresses and covenants through KP10 support microtransactions and programmable payments with some pretty advanced scripting capabilities. Plus, a Python SDK launched for developers, along with security audits for integrations like Zealous Swap. Multiple additional KIPs have improved efficiency, fairness, and scalability across the network. The remarkable aspect? The hard fork executed flawlessly without interruptions. No downtime, no emergency patches, no drama. Just smooth activation that immediately delivered the promised improvements. Since implementation, network hash rate has increased, miner decentralization improved, and solo mining became more viable. Beyond the headline speed metrics, Kaspa implements several technical features that demonstrate sophisticated engineering. Reachability provides advanced query capabilities for navigating the DAG topology. This matters because querying a graph structure is more complex than querying a linear chain, and Kaspa's implementation handles this efficiently. Block data pruning enables efficient data management through block header pruning. Full nodes don't need to store every piece of historical data indefinitely. They can prune older information while maintaining verification capabilities. This keeps node requirements reasonable even as the network scales. SPV proofs, simplified payment verification, allow lightweight clients to verify transactions without downloading the entire blockchain. This is critical for mobile wallets and applications where storage and bandwidth are limited. Subnetwork support lays the foundation for future Layer 2 solutions. Kaspa can handle ZK rollups, enabling a diverse L2 ecosystem that inherits Kaspa's security, censorship resistance, and MEV resistance while remaining tied to the main chain. This positions Kaspa not just as a fast L1, but as infrastructure that can support an entire ecosystem. Cryptographic receipts provide verifiable proofs of transaction acceptance. The harmonic mass formula prevents state bloat attacks where adversaries try to overwhelm the network with low-quality data. These aren't just technical curiosities, they're practical solutions to real attack vectors. The Rust implementation is remarkably efficient. Full nodes successfully run on Raspberry Pis, decade-old laptops, and mid-tier mobile phones. This accessibility maintains decentralization by keeping node operation affordable. When running a full node costs thousands of dollars in hardware, you get centralization. Kaspa deliberately avoided this trap. If this technical breakdown is showing you infrastructure that actually deserves attention, hit that like button right now. It helps YouTube recommend this analysis to people who care about technology, not just price action. And if you're not subscribed to TJ Crypto World yet, click subscribe and turn on notifications. I'm consistently breaking down the projects with legitimate innovation, not just marketing hype. Now let's talk about tokenomics. Kaspa launched November 7, 2021, with tokenomics that are almost unheard of in modern crypto. Zero premine, zero pre-sales, zero allocated coins. No insiders got tokens at discount. No VCs received allocations that unlock and dump on retail. The only way to obtain KAS initially was mining, starting with CPUs, expanding to GPUs, then FPGAs, and eventually ASICs as the network matured. This creates fundamentally different incentive structures. In typical VC-backed projects, insiders control massive supply at pennies, while retail buys at dollars. Those insiders systematically sell into any price strength, creating structural selling pressure. Kaspa doesn't have this problem because there were no insider allocations. So, the maximum supply sits at approximately 28.7 billion KAS. The current circulating supply is about 26.51 billion as of July 2025. The emission schedule, well, it halves once per year through these smooth monthly reductions by a factor of 1/2 to the power of 1/12. Right now, the block reward is roughly 4.9 KAS. Distribution analysis reveals a remarkably balanced ecosystem structure. Over 70% of addresses hold between 0.01 to 10,000 KAS, which really shows genuine retail participation. Mid-sized wallets, those holding 1,000 to 100,000 KAS, contain approximately 30% of the circulating supply, forming a strong community foundation. Large wallets above 10 million KAS control about 43% of supply. That might sound high at first, but when you compare it to other projects where 20 addresses often control over 50%, it's actually pretty healthy. Only 17 addresses hold more than 100 million KAS, representing 22.5% of supply. These are likely exchange addresses, which is actually a good thing. It indicates liquidity and accessibility rather than concentrated insider control. The name Kaspa derives from Aramaic words meaning silver and money, positioning it as digital silver to Bitcoin's digital gold. So, it's really meant to be a practical currency for everyday transactions, not just a store of value. Development really mirrors this community ethos. Kaspa is 100% open source, with all of its code up on GitHub. Contributors come from more than 16 countries, all participating transparently. There's no company controlling development, no foundation hoarding funds, and no token allocations paying insiders. This is genuine grassroots blockchain development. Kaspa represents more than just technical innovation. It's actually a return to cryptocurrency's original vision. Bitcoin's white paper described a peer-to-peer electronic cash system, but Bitcoin's limitations meant it evolved more toward a store of value rather than a true transactional currency. Kaspa maintains Bitcoin's security and decentralization principles while delivering the speed that's necessary for actual cash-like transactions. Processing 3,000 to 4,000 transactions per second with 10-second confirmations puts Kaspa, well, in Visa territory for transaction capacity. Unlike centralized payment processors, Kaspa achieves this through decentralized proof of work that anyone with the right hardware can participate in. So, the roadmap keeps moving forward. The initial Rust implementation is aiming for about 32 blocks per second. That's one block every 31 milliseconds. Looking ahead, future projections suggest that hitting 100 blocks per second is totally possible. That would mean over 10,000 transactions per second, all while keeping full decentralization and security intact. Layer 2 ecosystem development, well, it's set to expand Kaspa's capabilities even more. With the launch of smart contracts through Crescendo, we're talking DeFi, NFTs, DAOs, and programmable money, all becoming a reality. The technical foundation is now in place, so developers can build some pretty complex applications and still enjoy Kaspa's speed and security. This isn't vaporware or just some kind of theoretical scaling, you know. It's live, tested, operating infrastructure that's processing real transactions with real users. Testnet 11 actually ran successfully for years before the mainnet implementation, which really proved the architecture works under real conditions. The fair launch tokenomics combined with genuine technical innovation creates a project that's fundamentally different from those VC-backed alternatives that, honestly, just prioritize insider returns over user utility. Kaspa prioritized decentralization, security, and community participation right from day one. If this deep dive into legitimate blockchain innovation gave you a new perspective on what's actually being built in crypto, hey, show this video some appreciation with a like, and share it with someone who needs to understand the difference between real technology and just marketing narratives. Subscribe to TJ Crypto World if you haven't already. I'm consistently delivering technical analysis on projects that really matter. Drop a comment telling me what aspect of Kaspa's architecture interests you most. Let's discuss. Appreciate you investing this time with me, technology-focused investors. This channel exists to highlight genuine innovation in a space that's honestly filled with a lot of noise. Check out my other videos analyzing blockchain infrastructure and Layer 1 competition. Stay curious, stay informed, and I'll catch you in the next one.